Hi, we are Jose Cuesta and Diana Mora, and today we're going to be talking a little bit about the report that we made of our last field trip for the subject of marine pollution. So, I think that an important thing to mention is that the main objectives of this field trip was a social work because we were going to clean the beach, we were going to recollect some garbage, plastic debris, but also we took samples of water and sand so we can make previously granulometry at lab and also like see the water conditions because right now we know that we are in El Nino conditions, so we wanted to see how was the superficial temperature, salinity, and all of these factors. So we were in La Chocolatera, Santa Elena, as we have here. La Chocolatera beach is located within the Salinas Naval Base, at the most prominent point of the Santa Elena Peninsula. It is 163 kilometers from the city of Guayaquil. It constitutes the second most prominent point on the South American coast. It offers a unique spectacle full of colors, since here two sea currents come together that produce a crash of waves against the rocks and its waters are pierced by the intense solar rays, creating multiple rays. So, as I previously mentioned, we did took some samples of sand and water. So for this, we got divided into three groups so we can establish different stations. We were at station number 1. Here we have the latitude, the longitude, and in this picture we can see the exact point where we took the samples. So these samples were taken on December 9th of 2023. It was 12:18 p.m. and we have a temperature, an atmospheric temperature of 20.8 degrees, a salinity of 32.5 UPS, and a superficial sea temperature of 26.9 degrees. We took the samples here we have for the beach profile. We use the emery method. It's pretty simple. You took two reference points, you look to the horizon, and then you calculate the difference between these 2 points. As we elevation changes are then calculated by using the line of sight with the horizon and markings on the road as a reference. Knowing the benchmark elevation C, these relative measurements are then converted to actually elevation. For microplastic debris collection, we actually apply a method taught by a teacher. Here I explain it a little bit. This method consists of filling a bucket of approximately 5 liters with water collected from the shore. We take a quantity of sand where we can see that there are remains of plastic or possible microplastic. We place the sample in the bucket and mix the sand in the bucket with the water. You will notice how the microplastic floats, and then we filter this with a sifter and obtain the microplastic. Then this microplastic will be analyzed in the lab in a stereoscope so we can define what it is or where did it come from. And finally, we did granulometry as well in the lab with the sample that we took. And granulometry is basically the measurement of the size distribution in a collection of grains. It is also called particle size distribution test. It is often characterized by the percentage of particles with certain diameters ranges in micrometers.
The sample of plastic taken on the field trip on December 9 were a lot of considering that they were taken from only one station of 10 square meters. Its weight was almost 200 grams. Here there was found plastic coming from fisheries such as ropes, bottles, and other utensils. There was also found personal implements such as toothpaste, straws, spoons, nets, garbage, and many more. All of this, as it was mentioned, in a tiny space. The fact here is that it's a beach where it's not allowed to swim, and there's really a few people walking through it. So, we can assume that most of the microplastic that ends in the beach is carried by the wave from other beaches here in our country, or even because of the current, we can find plastic debris coming from other countries. Talking about the microplastic, in the stereoscope, one of the samples was under the detection limit. The balance from the laboratory couldn't measure it, but we do have data from the other sample, having a total weight of 0.28 grams. We can see in one of the samples some kind of small particles like crystal, a really tiny rock that we can assume that was about to erode. There are two shining small white balls that is difficult to compare or associate with some kind of material. They are similar to pears, but it's difficult to determine what they are. Now about the granulometry, we can observe that the curve is not very steep and mostly exhibits an inclining behavior. This indicates that there is a significant variation in the size of our particles. This variation becomes quite noticeable after the sample of pass-through sieve 40 and 60. Showing a significant decrease in particle sizes, we observe the same behavior after sieve 100, where there is a significant reduction. And in general, the beach profile at La Chocolatera exhibits relative uniform slope, indicating a stable coastal dynamic. The variation in slope suggests specific areas of interest for future studies on erosion and sediment accumulation. Comparison with standards will provide a more comprehensive understanding of the uniqueness of the beach profile in this location. Thank you.